Hello, welcome back to BLENDERSUSHI Live Coding. In this episode, I want to take a look at texture viewer once more, and I will use another simple functions that I have not used. It's basically the exponential functions. If I actually search for like a 3D exponential functions and I type in plotter, I actually get this kind of graph, right? This kind of graph, if you look at it, we don't always we don't always get it right away. But after some kind of thinking, I think when we make like a texture, like a procedural texture, we actually kind of using the function as like this as well, and then we kind of slicing, just get one slice of the objects noticeably, maybe from the top view. That's kind of the thing that I'm thinking. I think exponential function is something like this. Um, so this is kind of like a sine wave, but if we use the sine wave to generate our texture, we usually get like a stripes because we kind of slicing it. Um, I think that's the idea that I'm trying to kind of came across. I think this is the kind of function that we want to do today. Um, that's kind of like a math formula. This x exponential 2, this is the one that I'm going to be using. Let's give this a try anyway. Just visualize it, it's much easier. So I'm going to delete everything. File, save as. This is SV exponential. It's a formula, math formula, but still a very basic one. So for the texture viewer, I always start with a plane, because we know the plane will generate a bunch of points, right? And you can see how the points get arranged. The 0, 0, 0 is actually the first point right there, but we can switch to the center, so we can you're gonna see that it's gonna give us a different result. For now, we can leave it like that. 128 by 128 points should be good for us, and that's gonna be for our texture viewer. Small 128 times 128, so that's we need to somehow generate like a texture based on that. So I'm gonna separate all the vectors here, the vector points positions. We know that the x and y should have some values that's kind of growing, and you can see it here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then same with y. 0, 0, 0, but it has some kind of pattern. So after separating the x, y, z, if we use our functions, exponential functions, let's use math, and this one is actually exponential, this guy right here, to the power of something. We want to be doing like something like this. It's very, very basic. I think if I use these functions for a single value number, we should get this kind of curve, or maybe I draw it wrong. Maybe not, maybe more like hyperbolic, something like that. Let's just give it a try. If we use this guy, and if we try to output something, vector out, plug this into the, actually this should be a vector in. This should be the x, or maybe the y-axis. And for the x-axis, I want to have the original. If we compare, if we just look at the points, okay, it's kind of drawing that exponential 2, and we should have like a hyperbole. Look at it from the top view, orthographic. Okay, so you can see there's that kind of curve going on. Maybe I should try from 1 and then increasing it to 2, and perhaps even actually I guess it's sort of like making like a hyperbole. It's actually not like this either. It's more like that, upside down. So this is the curve that will be created if we just doing it in one axis. So anyway, don't worry about that. What we want to see is the result of this when we add the x and the y together. Math. I think we should get a circle. Well, we can see there's a white color there. Maybe make this even smaller. Ah, there you go. We get black somehow, which is weird. 0.1, and we have that black dot somewhere. That's interesting, but I will center our points, and you should see that the dot is actually at the center. So that's a good start. And let's see. Kind of wondering if we actually put all the points and look at the displacement made of these functions, maybe it's a bit more clearer. So viewer points, actually viewer draw, vector math, try the original points plus this vector, but this vector is going to be for the z-axis. And look at the result. There you go, that's the result. Maybe I'll make the points a bit smaller. There you go. From the one side, if you look at it from the front, for example, and then orthographic, oops, it looks, yeah, it looks more or less like that. That's the exponential functions. If we actually draw the so it looks like that, and but from the top we get like a black here. I was expecting slightly different. Maybe I should try something like a multiplier right here. Math. I'm adding a sine wave, and what do we get? Apparently we get this kind of result. Now if we plug this into the z, we get this. That's exactly kind of similar to this guy right here. Although it's probably need to be inverted. I don't know, maybe it's a cosine. Yeah, there we go. That's very, very interesting, right? So maybe switch this to 0.15. This looks like a drop of water place, but you can see there's like another like a circle being generated on that side as well, which is kind of weird. So this is how it looks as a 3D. If we plot it in 3D, we actually have some overlapping surface as well, which is really, really strange. Maybe I should just keep it simple for now. Okay, that's pretty good. File save as. But I think the idea is there's a correlations between that texture, procedural textures that being generated, and the 3D thing. If I kind of slicing, maybe I bake, if I bake this guy and then bake the original mesh and kind of compare the two. Oh, actually that's the original, right? I guess bake. Okay, if we compare this and kind of intersect the two, we should get something that looks like this ring being generated. So I'll give it a try. If I use Blender Boolean, just this guy, and see how many objects we have. Just SV0 and SV001. So Boolean and intersect with the other guy, or maybe difference. We should get this coning, maybe intersect, carve. Oops, maybe I shouldn't use carve, but yeah, that's actually intersect, carve. What's the other one? Bmesh. There we go. That's kind of result that I was expecting. So I think that's kind of give us a little bit more understanding about procedural texture, kind of, because imagine if we are generating functions that give us a sine wave, for example. If we're actually doing a slice, we should get stripes. And if we are doing, for example, a function that does this, we should get some kind of, what do we get? Guess it. Something that looks like a gradient, like a ramp, right? So that's kind of the idea that I kind of getting, even though it's not exactly like that. And this is only for the basic functions. Like this function probably give us like a spiral. It's not easy thing to make a spiral procedurally. It's easier actually to generate something that's kind of like a gradient ramp, circular ramp. That's actually easier to create than the cone, I think. For the cone, I'm not sure. I think probably we need to use some kind of math projections. So we need a sort of way to work with the 3D space or something like that. But anyway, there's at least this thing is working. Intersect union difference. Maybe I can try a different thing here, like modulo, for example. I'm kind of curious. Modulo give us even weirder result here. So if we plug that in and we can check the result. There you go. So it's more like a ragged kind of I believe we have like some kind of stepping happening. Maybe smaller value modulo. At some point, probably I will try to kind of compare the OSL method and this Sverchok method. OSL is of course it's like a compiled shader node that's gonna be working a lot faster. OSL is like something that you can plug into Cycles material and you can generate like a procedural texture that way. But with OSL, you have to type everything. I don't know if there is a way to kind of do OSL visually, but like I said in the previous live noding, it's not actually that simple. It can be a little bit more complex if we use nodes. It's actually a lot simpler using functions and kind of layering the functions, kind of put the functions together and being able to layer and doing the masking all within the code. That's gonna be a lot easier. What we are doing here is really super basics, very trivial kind of stuff, but still I still found it interesting that this function actually generate this kind of objects and actually generate this kind of texture. So you can try with other function like our easing 0 to 1 actually has the exponential like bounds. These are all functions, and if you dig inside the code, you will see that this function is built in Blender. That is something that you can just use in the code, and we have it like a preset like this, and you find it everywhere in even in animation curve to generate a function that's procedural. Yeah, but anyway, it's another look at the simple functions. It's these exponential functions that generate this guy, and if we mix it with a sine or cosine, we get something like that. If we look at it from one side. Anyway, it's just a experimental thing. If you have anything to add, anything to ask, just ask in the comment below, and then we can figure out together. Thank you again for tuning in. I'll see you in